Gravity. With the fall of the banana, a question pops into Monkey's head. Why bananas fall to the ground? Why no fly up? Why Monkey falls? Why can't Monkey go to the stars? It all begins with these questions. Monkey encounters the most fundamental and extraordinary force in the universe, gravity. And through these questions, Monkey will simply discover the universe's extraordinary, ancient power. Monkey thought again and wondered, could it be that the thing causing the bananas to fall is a secret vacuum hidden beneath the ground? No, Monkey, it's not a vacuum. It's gravity, one of the oldest and quietest agreements in the universe. Monkey is fascinated. Monkey asks, what happened to the world without gravity? Why gravity weaker in space? Explain, explain. That's an extraordinary question, Monkey. I'll teach you everything, including the law of attraction, gravitational pull, centrifugal force, curved space-time, the role of gravity in planetary formation, and everything else you've asked about. And all with just a banana. In every corner of the universe, everything, but everything, attracts each other. This is Newton's law of gravity. Let's break down Newton's law of gravity a bit more, like a banana peel. Actually, you're gently pulling the banana on the tree, and the banana is pulling you. You're even pulling the banana on the farthest tree right now, but you're pulling the banana on the tree closest to you more. Because the closer the bananas are, the stronger the gravitational pull. The Earth pulls on the banana, and the banana pulls on the Earth, but the banana falls to the ground. Nothing happens to the Earth, because the Earth is heavier than the banana. The greater the mass, the greater the gravitational pull. The objects with the greatest mass in the universe are black holes, which possess the most extraordinary and fascinating properties in the universe, and they seem to swallow up all the bananas around them. Monkey was amazed by what it had learned. Today, Monkey will be even more amazed. Every banana with mass attracts every other banana with mass. This is called gravitational pull. I already explained this part in the law of gravity. However, the effects of gravitational pull on the universe are incredible. Gravitational pull is the most fundamental banana that enables the universe to function. The hot banana system also works thanks to gravitational pull. Hot banana is a very large and massive object. Therefore, it exerts a strong gravitational pull on its surroundings. All other bananas orbiting nearby, from Mercury to Neptune, are pulled toward the hot banana by this gravitational force. This is gravity. However, these bananas have their own forward velocity. In other words, these bananas want to move in a straight line. But since the hot banana pulls them toward itself, they cannot move forward. As a result, the banana tries to go straight. The hot banana tries to pull it. The combination of these two forces causes the banana to follow a curved path, which is the orbit. There is a balance in this system. If the gravitational pull is too strong, the banana falls. If the speed is too high, the banana escapes. But if the speed and attraction are in harmony, the banana stays in orbit. This balance is also called centrifugal force. This situation is similar to spinning a banana tied to a string. The banana wants to go straight, the string pulls it inward. As a result, the banana follows a circular path. This is how bananas move in space. The hot banana pulls with its mass. The rotating bananas want to move straight ahead with their speed. Thanks to this interaction, the planets continue to rotate in a fixed orbit. Thus, the solar system is formed. The cause of tides in oceans and seas is also gravitational pull. A tide is the rise and fall of this water layer during the day. The most important reason for this phenomenon is the gravitational pull exerted by the moon. The moon is a banana close to Earth, and due to its large mass, it pulls the water layer toward itself. The water on the side of Earth facing the moon rises slightly. The hot banana is also involved in this phenomenon. The hot banana does not pull the water as effectively as the moon, because the hot moon is far away. The moon is close. When the moon and the hot moon align, these gravitational forces combine, and the tide grows. This phenomenon is called a spring tide. Monkey loved learning about gravity. Monkey was excited for the next video and left the topic he wanted in the comments. We've come to the most confusing phenomenon, Monkey, the curvature of space-time. Yes, I know. But you won't get confused. I'll explain it with bananas again. According to Einstein, space is not just empty space. Space and time move together. This is called space-time. Space-time is like a flexible banana peel. And this banana peel bends with every banana placed on it. When a hot banana is placed on this banana peel, it creates a curve toward the center. So the part of the peel around the banana is curved. And even if the bananas around the heavier banana go straight, their path becomes curved, so they end up orbiting the hot banana. Since time bends along with space, the closer you are to a heavy banana, the more time slows down. It is unimaginable, with a mass many times greater than a hot banana. And in black holes, time seems to have almost stopped. What we call gravity is actually the curvature of space-time. Gravity and planet formation? How does it affect them? Explain. In the early days of the universe, there were countless small pieces of matter, dust, and gas particles floating freely in the void of space. At first, each piece of matter had only a small, very small mass. But they did have some mass after all, and of course, they began to attract each other. First, nearby dust and gas particles began to merge due to gravity. As a result of this merger, slightly larger clumps of matter formed. As the mass grew, the gravitational pull of these newly formed clumps increased. They attracted more dust and gas particles and grew into even larger clumps. This process repeated itself over and over again. Gravity not only brought these particles together, but also determined the shape of the resulting clumps. Since gravitational pull is applied equally in all directions, these growing clumps gradually became spherical. Each of these spherical and large clumps eventually became a large planet, just like Earth. In conclusion, without gravity, the dust and gases in space could not have come together, monkey. Bananas could not have formed, and regular structures like the hot banana system would not have emerged. Gravity is the fundamental force that determines both the birth and shape of bananas. Monkey loved it. Monkey loved physics. Monkey subscribed to the channel. What happened to Earth when no gravity? It would be a complete disaster, monkey. First, when monkey took a step, his feet would not touch the ground. The moment you lifted your foot, you would not be able to land on the ground. You would remain in the air. You would not be able to put your banana on the table because the banana, the table, and you would all start to float upward. The surface of the Earth would no longer be able to hold any monkeys or bananas. Then liquids would go out of control. Water would overflow from cups. Oceans would swell and spread like clouds. Water would no longer want to go down, but in every direction. Then air molecules would abandon their positions. Yes, monkey, air is on Earth, thanks to gravity. It would escape into space. Within a few minutes, oxygen would run out. Pressure would drop to zero, and life would become physically unsustainable. In the next stage, monkey, the Earth's internal structure would begin to break down, starting from its core. Gravity is what keeps the Earth's spherical shape intact. Without this gravitational pull, the layers would break apart and magma would spread across the surface. The Earth would first separate from its crust, like a peeled banana, and then its interior would disintegrate. Rock, soil, banana, everything would scatter into space. Of course, you too, monkey. Don't forget to share the video. See you later.